Okay, so we're actually going to be looking at one of the problems from your packet. It's on the last page of your packet in the implied density problem. It's actually the last problem. So this is what we're going to work through together because it gives us a little bit of everything with density. So it says a standard backpack is approximately 30 centimeters by 30 centimeters by 40 centimeters. Suppose you find a hoard of pure gold, awesome, while treasure hunting in the wilderness. How much mass would your backpack hold if you filled it with gold? And then we think about an average student who has a mass of 70 kilograms. How do these values compare? Okay, so I know if I'm going to talk about density, I need to talk about mass and volume, right? Because density equals mass over volume. It's the ratio of mass to volume. How much stuff is in a certain amount of space? So I know the mass is not 70 kilograms. That's what we're comparing it to. See, there I go, making the common mistake. I'm just jumping to whatever I see. I know I'm trying to find the mass because it says, how much mass would your backpack hold? So that's a question mark. Now, volume I don't have, but I do know that volume equals length times width times height. And I do have a length, a width, and a height. So I can do 30 times 30 times 40. That's all centimeters. So it should end up being centimeters cubed. So let's get that volume. Now I want you to know that it's 30 dot and 40 dot, which means those numbers are all 2 sig figs. So when my answer comes out to 36,000 centimeters cubed, I get to keep it like that because that is 2 sig figs, as long as I don't add a decimal to the end. Okay, so that's my volume. Density. It's the density of gold. And from previous questions, you know that the density of gold is 19.3 grams for every cubic centimeter. So from here, we could just set up a little algebra problem. I've got 19.3 grams. I can rewrite that as if I want it over 1 cubic centimeter. You don't have to rewrite it like that. But for me, algebraically, I like to rewrite it as a proportion over x grams equals 36,000 centimeters cubed. And you can tell that my units equal out, and that's always a good sign. So if I go ahead and solve that algebraically, I'm going to do 19.3 times 36,000. I want to multiply both sides by 36,000 to get it out of the denominator. And I find that x equals 694,800 grams. That's a lot of grams. Now it asks us to compare that to 70 kilograms. So I'm going to convert that to kilograms just so we're on the same page here. And actually, first, I'm also going to put this in the right number of sig figs. This should still have 2 sig figs, so 690,000 grams, which would give me 690, no decimal point, kilograms. We compare that to 70 kilograms. It turns out that that gold backpack is actually 10 times heavier than the average student. So if you filled your backpack with gold, I don't know that you'd be able to take it very far. You'd really be dragging it behind you because gold is extremely dense, and it turns out much, much more dense than what a student might be, because you are much larger than a backpack, and you would still weigh 10 times less than that backpack full of gold. So there you go, a little fun application and also a little bit of math.